Good evening.
Right. So for those who have not received notes, notes are now available. You can just collect from Ms. Lakmali, because like July and August note together you can collect, right? So both notes are there. And actually we have already finished the lesson, and we have to go through this workbook. But most of the activities in the workbook is also completed. Therefore, I will quickly go through the note first, and then after explaining the note, after revising the note, then I'll be moving to the workbook, right? Okay, using microcontrollers. So we just learned microcontroller. Microcontroller is a single board or single chip computer. So which is actually a small computer, right? These speciality of these microcontrollers are, so these microcontrollers are basically working by sensing the environment, unlike the computers. Because computers we need to give the input. For computers we need to give the input, but for the microcontrollers to work, it can just take the inputs from the outside world, sensing the change in environment. Sensing the change in environment, it can get the inputs and produce outputs accordingly. Means, so maybe light changes, maybe sound changes, motion changes. So it can either way, like it can be a timer, time change, or it can be change of inputs, manual inputs by people. So that can also be taken, not just sensors, manual inputs through the switches, that can also be taken. So those are the microcontrollers. And we learn about the microbit. So you can see here, this is a microbit related code. We learn about the microbit. And so that is easy because all the sensors, almost all the sensors are integrated to microbit. So we can easily code microbit by adding the blocks. And the related code is also given. Actually, coding part you don't need. So if you know the block coding part, that is enough for the examination. But if you are interested in learning coding, you can learn. This is like this code, you can see it is JavaScript. You can learn that as well. Okay, so then we learn how to produce inputs, how to change numbers. This actually show number. This number part in microbit can be used to display the temperature, maybe the angle, temperature, speed. These numbers can be displayed using show number. So you can directly drag the input from the microbit interface. For an example, if you want to show the temperature, let's go to make code microbit link. Okay. So if you want to display the temperature, you have two blocks basically, start or forever block. Let's say on forever, I just need to display the temperature of this. I can just view this from the basic. I can take show number, the very basic element, show number. Then I can put from the inputs, I can show temperature. Okay, then when I run this, it's showing here 21. That is this is a virtual temperature, it's not real. It's displaying the temperature. And it can be so these inputs are different sensors, right? So when it can be acceleration, it can be acceleration. So say this. Then you can actually move this, because otherwise, like, it's harder to see the acceleration. When you move that, and you can see the acceleration. Actually, you have to move move the board, then only it shows the acceleration. And not just that, acceleration, then you can show what is the light level, compass heading. So these are some example inputs given by the sensors. You can see this is 128, that is the light level. Okay, similarly, you can input different things. These are the sensor readable or values read by the sensors. These are the values read by the sensors. Okay, then let's move to the next part. After that, we just discuss about different sensor implementation related to Arduino using C++ coding. So Arduino is a bit expandable because like sensors you can connect externally, and we learn about how to connect a breadboard using a breadboard wiring. How can we connect the breadboard? And also we learn about different type of signals like analog signals, digital signals. Okay, this analog digital signal, the specialty of digital signals, it has discrete levels or specific levels. Discrete levels or specific levels. That is why it's called digital. Discrete levels, specific levels. That is why it's called digital. You can see this is one level, this is another level. This can be like mostly digital. So when it calls digital, people think it is like this. That is also not wrong. That is also correct. That means digital has only two status. Digital has only two status like this. 0, 1. So digital can have two levels like this. Or it can have many levels also. Doesn't matter. And so analog is actually if it is taking values between any value between a given range. If it takes any value between a given range, not any value, it's any value between a given range. For an example, human hearable sound range 20 to 20,000. Human hearable sound range, it is 20 to 20,000. It is a value between a given range. If it can take a value between a given range, we call that, right? We call that analog signal. So analog signals are more common. Temperature is analog. Then velocity or the speed can be taken as analog. Then so different things are there. Speed, temperature, and maybe speed can be taken. Temperature can be taken. You can take gravity, mass. So these are some analog values, right? Analog and digital. Okay, that's it. And so both analog and digital inputs, outputs are supported by this. So you can see A0, A1, A2, these are analog pins. And then you have 0, 1, 2, 3, 4 up to 10. So 10, 12, 13, these are digital pins. Right? Arduino has both these. And then, okay. So then we have learned the places where the microcontrollers are used. This is actually a workbook activity. Where the microcontrollers are used, you can write anywhere. You don't write anywhere, but just mention. So automatically turn on, turn off lights, sensing environment, the conditions, animal feeding systems, auto braking systems, alarming systems, security conditions, security alarms, obstacle avoiding robots. So, you know, hand dryers in washrooms. And right then, door locks, automatic door locks, and then elevators, automatic elevator systems, then driving support system, railway gates. Can you tell more? So where else it's used? Use of microcontrollers, where else it is used? Can you give some idea?
In street lamps.
Street lamps, yes. Hand dryer spellings are all right. R-Y. Street lamps, then. Yes, street lamps. I think I have given that turn on, turn off lights. Yeah. Anything else?
Door locks.
Okay, door locks. Yes.
Sir, door locks is the seventh one.
Seventh one is yes, automatic door lock is given. You can say in agriculture. So in different areas in agriculture, in manufacturing. These are in education. In education, these are industries. In manufacturing, education. Right, in this, so no limit, right? You can say in transportation, in business, in researchers, right? In researchers.
Exploration, space exploration.
Yes, space exploration, space science. Satellites, communication. So everywhere it used, right? You can mention. So the first few examples are specifically given. The second set of examples that I wrote now are just fields. Those are not specifically, but those are fields, right? And so write down advantages and disadvantages of using microcontrollers with sensors. Can you tell? Can you write down this and actually finish? Fill in this. Please write down at least 5 advantages, 5 disadvantages. Please write down this as a question. Write advantages and disadvantages of using microcontrollers with sensors. Advantages and disadvantages of using microcontrollers with sensors. And please write 5 advantages, 5 disadvantages. And you can send it to me in the chat. If it is advantage, so send it separately, right? What are the advantages? What are the disadvantages? Send it separately. You can send it to the chat. Right? So these answers I'm comparing. So operating system can be installed in a microcontroller. Operating system can be installed. And it can be reprogrammed as well. And multitasking can also be done. All these are possible with the microprocessors, right? Yes. Right. Okay. So these are the things that I have listed. You can write down this. Some are there in the notes, some are not. So please write down. Fast and efficient. It saves time. It's not getting tired. Low cost. Easier, convenient. So running 24 hours, 7 days, all year. Can be synchronized easily. And as you said, can be reprogrammed. Can be reprogrammed. That is also an advantage. And can be used in the environments. Please write down. Can be used in the environments where people cannot reach. So you can reach remote environments like space, sometimes like, in certain dangerous activities like underwater or volcano monitoring, like, so different dangerous activities are the tsunami monitoring, and can sense beyond human limitations. So, example, you can say human hearable range is 20,000 hertz, but sensors can hear ultrasound even. Normal sound can be heard and ultrasound can even be. So it can go beyond the human limitations. That is also an advantage. Okay, let's write down these factors. And it's portable, right? It's portable, another thing. It is portable. That is also an advantage. You can write down that. It's portable, can move easily. Okay, the disadvantages: initial cost is high, technical failures, power consumption, increase in unemployment rate, because this microcontrollers are employed, then you will lose jobs. Traditional jobs will be security risk of hacking. Everything depends on the power. That is another problem. E-wastage will increase with the time. Electronic wastage, electronic garbages will increase over the time. Right? Electronic wastage or electronic garbage will increase over the time. And what else? In case of error, it might give wrong suggestions. In case of error, it might give wrong suggestions. So it's not 100% trustworthy, right? It's okay, it's accurate. That is a problem. So what else? Any disadvantages other than that? Hackable, right? This hackable security risk is there. Okay, sometimes like it emits its materials, right? Harmful rays. Harmful rays. Sometimes its materials emit harmful rays. Sometimes, not always, right? So like X, maybe alpha rays, gamma rays, right? Alpha rays, gamma rays, these are harmful. So those some elements are there, some elements like mercury. So these like mercury is not the issue in rates, but the thing is it can easily spoil water resources. So environmental pollution. Right, that can happen. Environmental pollution can happen. So these are disadvantages. So please write down these factors and indicate once you are done. Right, the next is, okay, we learn about the ultrasonic sensor and also PIR sensor, and one more thing. So digital divide and digital bridge, this I couldn't discuss. So digital divide and digital bridge, these are some important terminologies, important terms in terms of like digital divide is where, so basically you all and like there are people, so in Sri Lankan context actually we have like less audience learning ICT. The reason is like we have given that optionality to the school children. So school children will think that the main subject like mathematics, science will only matter. But actually speaking, most of the countries, even the European countries, they have given priority to ICT because ICT is one of the main concerns. Without ICT, the other subject cannot be learned according to their concentration. The reason is like, so most of other subjects are also using ICT. ICT is an umbrella subject, therefore ICT is a must learn component in most of the curriculums in foreign education. But in here, so we have some upside down education system. So we are not identifying the priorities. We don't learn that. So actually we are not ready to learn. So don't know why. Even the parents are not concerning. So for an example, if same day ICT and maths class is there, the priority will be given to the maths class. I'm not telling that the maths shouldn't be learned. Maths should be learned. But the thing is ICT will have same priority. That is the thing. So, but anyway, so due to that reason and some reason, you see that currently QR system, how many people struggle, how many people say no to that system? The reason, mainly because this digital divide, they think that this is inconvenient. They are not ready to change. They are not ready to change the system. Even the fuel stations are ready. These people were rejecting them because they are not ready to change. Actually change to the ICT technological solutions, but the technological solution is always better than non-technological solution because it can be automated, but the accuracy need to be maintained. So when there are errors in the technological system, it is worse. It is worse than the manual system. But when accuracy is maintained, when the system is up and running correctly, then the electronic system is much better than the manual system. Okay, so what is digital divide? Digital divide, actually, we divide people into two groups, the people having IT knowledge and the people not having IT knowledge. The people having IT knowledge and people not having IT knowledge. That is the two groups. Basically, the people not having IT knowledge will be penalized. So they will be affected. Why? So they will be neglected, affected mentally or physically or economically. They are affected. Right? So that is digital divide. The digital bridge is acknowledging them. Digital bridge is basically make them aware about ICT and technology, help them learn ICT, help them learn technology. That is digital bridge. Actually, so we should put some effort on bridging these people together. Those who are having ICT knowledge and those who are not having ICT knowledge. Those are two groups. We have to bridge them. We have to merge them by giving ICT knowledge. That is digital bridge. I hope that concept is clear to you. And new ICT careers. New ICT careers. These are also very important. So what are the careers, the recent careers? These are like I have omitted or I have skipped. There are some new careers like even software developer, web designer, graphic designer, multimedia authoring agent, or digital marketeer. I just skipped that. These jobs are also, those jobs are also there. So these are much old, right? These are, so other ICT careers. These are not new, but you can add these careers like new ICT careers and please add the other ICT careers. First of all, let me explain the new ICT careers. White hat hackers and security professionals. There are two types of hackers. Out of that, the white hat hackers are kind of legitimate people. They are genuine in the way it's like police. The police also using weapons, no? But they are using it. They must use, I don't know whether they are using that purposely for harming people, but the thing is they must use weapons for protecting people. So that is the oath. They must use their weapons to protecting people. So similarly, the white hat hackers are also hacking, but for betterment of the society, betterment of the people. That is why they are hacking. But they are also called security professionals. So that is a kind of game developer. So games are there. The development of games is really, this is a demanding career, game developer. Artificial intelligent agents, scientists. Right? Artificial intelligent agents or scientists. And then blockchain developers, big data scientists, those who are analyzing data. So we group into big data scientists. They are taking decisions based on large volume of data, millions of records. They analyze millions of records and get the idea. For an example, think that you are interested in some subject and you are searching in Google. So when you visit YouTube, that automatically appears. The suggestions automatically appears. Canada. You have planned to migrate Canada, therefore you are searching about Canada in Google. But when you visit YouTube, that automatically appears. The details about Canada will automatically appear. Why? There is a task, underlying task going on. So the big data analyst and automated big data analyzing big queries or big data analyzing related things, which is happening in the underlying layer automatically, will suggest YouTube, hey, this person is interested in searching Canada. Please give him more related videos. So that is artificial intelligence plus big data. Like the decision taken, analyzing large volume of data. That is called big data. Blockchain developers. I think you heard of Bitcoins, anonymous currency. The currency which is not belongs to a specific country. It belongs to everywhere, all the world. Anyone can take these currencies and work it. So there are a group of scientists, engineers working on that. Those people are called big data analysts. Drone operators. Right, drone operators, or we call drone pilots even. Drone operators, drone pilots. These are the people who operate drones. So those are also pilots. They are also trained people. So so we are using drone for like toys and all. We are using drones, but the thing is, so this basically, right? Basically, especially this group of people, right? They are trained specially in drones. They are trained specially about drones, right? So these people are called drone operators. And digital weapon engineers. So weapons are now, it's not traditional anymore. These weapons are now digital, having software component in it. So those people are called digital weapon operators engineers. Xenobots, we learn about the biological robots, not just IT scientists, not just them. So people who learn biology and people who are interested in learning earth science, biological science, about the living beings, they are also into these groups, engineering class. So xenobots. Then bioinformatic engineers. So those group, the bioinformatic engineers, they want to learn biology, information technology, and engineering, all three subjects. Biology, information technology, engineering, all three subjects. Once they learn, so and merge these subjects, they can become bioinformatic engineers. Mainly doctors, some group of doctors, they are also into this category, bioinformatic engineering category. Quantum computers, future computers. Still, currently also there are quantum computers developed. These quantum computers are high-speed computers. So which is 1,000 times faster than the current computers. Right? So these quantum computers are in place in future. And content creators, you know, YouTubers, Facebook content creators, content managers, cloud architects, the software which works on the cloud. So, you know, some software you don't want to download, you can just go and type the software name and you can use immediately. So those are called cloud software. This cloud software, this is one example, Photoshop like software, which is Photopia, it's a cloud. and cloud architects, mobile application developers. So what are the other careers? You can write down this. So other ICT careers, can you tell me few? 15? Yes. Software engineers.
Drone cameraman.
Yeah, drone cameraman is drone pilot, right? So you can say photographers generally. Then multimedia.
Video editors.
Authoring, yeah, that all are belongs to this category, right? Multimedia, authoring, photographers, all these people, graphic editors, video editors, animators, web designers, web developers. Designers are working front end, developers are working the back end, server side. Designers are working front end. What we see, those things are developed by the designed by the designers. What you cannot see are developed by the developers, programmers, database engineers,
System analyst.
system analyst. These people are suggesting system designs. Tech leads. And IT managers. Right? These are also there because these jobs are, for a long time, these jobs are there, hardware and network engineers. Business process outsourcing officers. These are some other categories. There are, so you can see if you search IT jobs, IT job titles, there will be more than 100. So that is the thing, like that is. So that is what we are not focusing. If you see doctor titles, there are a few. There are a few specialists that there are closer to 30, 40. But all are doctors in generally, but there are some specialties. So similarly, nursing, we have few jobs. Engineering, traditional engineering, electronic, electrical, so we have few, but when it comes to IT engineering, there are many. And actually engineering has a, it has a broad, it's a broad field. You can get different employments, different ways. Commerce related things, like you have accountant, accounting jobs, marketing jobs, sales, management. There is a limitation, but when it comes to IT, unlimited opportunities, a lot of opportunities are there. That is unlimited. Okay, finish writing. Or do you need more time? If so, please tell me, right? Use the size. Well, let's quickly go through the workbook. Check whether we have covered everything perfectly. Grade 9 workbook, English medium. Okay. Microcontrollers, use of microcontrollers. List of advantages. Yes, we have done advantages, disadvantages both. And make a list of equipments in the, yes, we have listed where the microcontrollers are applied. So then we learn about this microcontroller. So basically microbit. How do we convert to show string just to display show number is to display the values, right? Show string to display text, show number to display values like this. We just discussed that. And clear string to clear the string. So then we learn about Arduino, Uno. Yes, we learn about the setup and loop and also the coding platform, how LED can be blinked, LED blinking 13 pin, and how can we use PIR sensor, passive infrared sensor. We just discussed week before last week. And then we learn about using ultrasonic sensors. So which is the distance sensor, another name for this. Okay, I think that's it. Right, now we have to start the lesson, computer networks. So please go to the last line and write this, computer networks. Computer, okay, what is a network? What is a computer network? So that is our new topic. What is the computer network? So basically there are two or more computers or computing devices. So it can be connected. There can be two or more devices, two or more computers or computing devices, which can be connected using wired or wireless media. It can be Wi-Fi or Bluetooth like wireless media, or it can also be a wired media like copper lines, fiber lines. It's a wired media. So what is the purpose of connecting devices? Can you give me a few?
Data transfer.
Yeah, data transfer and communication is one important thing. Any other thing other than the data transfer and communication? Any other usage? Other than that? Communication is one primary usage. Anything else? Yes.
Doing activities like gaming.
Network games, okay. So that one common term, you can use one common term to frame all these things. Gaming, using internet, just using one connection.
Network.
Saving, that is network. So you are telling basic terms. So I'm not asking that. I'm asking usages of networks. So what are the usages? So one is communication, obviously. Obviously, communication is one main thing. So what is
Data sharing.
sharing? Yes, sharing, not just data, sharing all the resources, not just data, sharing resources. Resource can be internet, can be a game, can be a software, can be data, can be a database, can be a printer, can be a anything, right? Can be a internet connection, can be a file, folder, application, a server. So all are resources. Okay, please write down the definition. A computer network is two or more interconnected computers or computing devices. So these computing devices can be smartphones, devices with microcontrollers, tabs, laptops, anything, right? Device, any computing device, not printer, monitor, not those things, not the components, computing devices. Two or more interconnected computers or computing devices using wired or wireless media for the purpose of resource sharing. So what are the resources we are going to share? Internet, storage, printers, etc. can be shared. Data, resource sharing, and communication. Resource sharing and communication.
example, you can say, pair your mobile phone with computer for internet sharing as mobile hotspot. That is, everybody has done that, right? I think you all know how to share, how to establish a mobile hotspot. That is a network. School, local area network. And the larger one, internet. That is the big brother, network of networks. Big brother, a network of networks. Okay, a network of networks. Right. Now, actually, we have to discuss more about the networks. With this, I'll conclude for today. Next day, I'll be discussing more details about networks, how networks can be created. So what can be done? What can we do with the networks? If you have two devices, make it ready. For an example, your mobile phone and laptop, mobile phone and computer, or two mobile phones. If you have two devices, so make sure those devices are ready by next day, because I'll show you how to establish a network and how to share a resource using that network. Therefore, if you get any two devices, please be ready. If you don't have, don't worry. If you have, be ready, be prepared. Okay, I'll stop from here then. Good night. See you all next week.
Good night, sir. Thank you.
Good night, sir.
Thank you, sir. Good night, sir.